thank you all for coming. My name is Michelsen. I'm from the Interactive Institute in Sweden, in particular from the Gothenburg studio. And I'm here representing my colleagues to talk about this project we're doing right now in cooperation with the museum. So, just short about the Interactive Institute. We are a Swedish research institute, and we were founded in 1998. And around 60 employees with studios all over the country. And we mainly apply for research grants, national research grants, but we also work a lot in the EU with other countries here. But I'm here to talk about this area here, which it may not look so remarkable from here. There's a road going right through it. This is the main road up to Oslo. This is about 1.5 hours north of Gothenburg. In the municipality of Tanum. But this is a World Heritage Area due to its many rock carvings from the Bronze Age and unique natural values. Right now, the Swedish Transport Agency is building a new highway which goes on the outskirts of this area. There is also a museum here called Vitlycke Museum near one of the largest rock carving cliff sides. So, as part of this building of this highway, the E6, the Transport Agency is building a rest stop overlooking this area. And it will be a building here and a walkway extending out from the cliffside and overlooking the area. And so, this is a deal with the museum, and the museum wants to have something really interesting. A new way to engage these visitors who maybe aren't aware of the history of and cultural significance of this area. So they contacted the Interactive Institute to create some kind of solution, digital, to really reach visitors with such a low barrier of entry as possible. So we did this with a participatory design method where we tried to involve as many stakeholders as possible, from the municipality, from the museum organization in western Sweden, Västarvet, and of course the museum itself. We held workshops, we body-stormed, tried to get a feeling of this challenge. And at the Interactive Institute, we have this notion of IT, not merely as like gadgets which you use for, in this case, an exhibition, but as a design material. And if you understand like what the possibilities are and how you can use technology, you can really create something special, and maybe to a much lower cost than if you just used like very, very specialized hardware and such. So the concept we came up with is this kind of digital binocular station, which will be on the far edge of this walkway and look out over the landscape, where visitors will be able to pan the view just like they expect from a tourist binocular station, but where we can also add a lot of new digital content. And I'll just start with some of the hardware challenges, but then move into the storytelling aspects of this. There are, of course, this binocular station, and this is the view from the walkway. There are harsh weather conditions here for having an IT deployment. It will be unsupervised, open to the public, and it will be vandalized sooner or later. That's just something we need to accommodate for. And we need to keep costs down of the individual units. There might be a lot of people visiting. Tourist bus may stop. So we need to have possible to share the view to other people. Only one person can actually view in the binoculars, but we need a way to share it with more people. And we want to have a solution which we can continue developing in other contexts to do more research. So by mapping the constraints of a place, it's far to the horizon. Maybe we don't need to be able to tilt the binoculars. It's also most of the things you will view through the binoculars are far away. Maybe we don't need stereo cameras. This allowed us to simplify the hardware a lot, and I should mention that this is currently a work in progress. We have done a lot of testing in public places with the early prototypes, but not all the final configuration hasn't been tested with the museum material yet. But as it looks right now, is basically an internal box, 3D printed, which houses all the main electronics, in this case a smartphone, a weatherproof smartphone. This provides a screen with special optics, makes it possible to get a stereo view. Use the smartphone camera with optics to get a zoomed in image of the landscape when you look through it. And currently we are using a rotation encoder to detect how you rotate the binocular station so that the digital content matches up well with the view of reality. But we are looking to remove that and just using what the smartphone sees through the camera to recognize landmarks and panning, so we can make it even simpler. But by using this, if something happens to the phone, we can replace the inner plastic unit in the outer metal shell. Or if the outer metal shell is vandalized, we have a simple specification to create new ones. And we did this in an iterative design process. We used Oculus Rift virtual reality headset with 2 cameras on it for the first prototype. That was actually the most complex prototype technically. It required its own computer. But then we could simplify it by thinking of what the parameters on the scene were. And these were all tested at various fairs and such, so a lot of people could go up and test, and we could see if our interaction model worked well. And I will talk about this interaction model a bit. But I just want to mention that we get this flexibility of moving between platforms. PC, there's a smartphone in here, is an Android phone, by using what is mainly game development software, Unity, but it's also used by some visualization companies and such. It allows us to use all kinds of media in our storytelling, and easy to network. We can have a separate screen nearby showing what the binocular sees, so that people can watch that if they can't get to the binocular because it's full. And there are many plugins we can use for all kinds of extending by more cameras, extra sensors and such. So, the actual presentation and how the museum shall extend its storytelling to this new medium. Our idea is that when you pan this around, see the landscape, and you see points of interest marked out in the landscape, overlaid on this live video feed of the landscape. And when you pan the binocular, so this kind of aiming thing in the middle, it shouldn't look so much like a gun sight. This is actually a Bronze Age symbol, but unfortunately it looks a bit like a gun sight, so we changed that. When it's over one of these points of interest, after a short timeout, you activate it, and it could either zoom in to this point of interest, digital zoom, going over to some material already made. You could change the whole view to a big panorama, which totally replaces the existing view. And there are a number of such things we could do. And some of the ideas we want to present is the land rising out of the sea. I'll explain that soon. Life in settlement in the Bronze Age. At night, when you can't see much, maybe you could see campfires at night. And we also could show aerial video. So the storytelling challenges here are that the museum's current exhibit, it's rather new. It's mostly hand-drawn and has these characters that come back all the time. So we want to show that. But at the same time, there are some things you maybe want to show realistically. So it's realistic rendering versus this hand-drawn style. So it's realism versus coherence with the existing exhibit. And of course all the storytelling here needs to have a low barrier of entry, because people are only visiting a short time, but still convey abstract concepts like time travel and isostasy, that the landscape is rising out of the sea due to the Ice Age. And it shouldn't, one thing we realized early with our workshops with the museum is it must complement the existing exhibition, not replace it. People should leave wanting to find out more and plan plan the real visit to the area after stopping at this rest stop. I mentioned Nordic isostasy. During the Ice Age, the whole Nordic region was under several kilometer thick layer of ice, which forced the Earth's crust down. So the land is still rising about 8 millimeters per year, which means the water level is moving away from the land. So this landscape looked very different during the Bronze Age, and many of the rock carving sites were near water. We want to give visitors a bit of a wow factor here. So we're going to have photorealistic water over the existing view from the binoculars. And we'll actually start with, when they trigger this visualization, they will be underwater with the fish swimming in front of them. And then the water will move down. We don't want to move back in time and have the water rising, because that doesn't make pedagogical sense. We might also have a time counter. So to also show a sense of time scale, when we visualize these rock carvings, we will have people working here, different people at different ages, because some of these, this is the largest one, this was carved over a several thousand-year period. So we will show how the landscape changed, got colder over time, the water level moved down, but this will be done in a painted style, painted animations, similar to the existing exhibition. And finally, we also want to show the present-day area, and this will use real photographs. And technology such as these drones, we have a couple at the studio, really make this kind of content accessible to gather. The museum isn't actually visible directly from the point of the binoculars, it's behind a hill. So we're going to have aerial photography moving from the museum, or from the binoculars to the museum, and to different rock carving sites, so people get the feeling of the present-day landscape and can plan their trips. But finally, we are making this technology also because we want to do some future research on it. This is kind of a mobile unit of the binocular station, and it's possible that we can make these well, they are already so cheap, they could basically be handed out instead of audio guides, and visitors could use their own smartphones. And this is something we want to explore more in the future. We are also very interested in seeing how this could be used in city planning, having multiple deployments, showing tourist information, maybe visualizing underground infrastructure, opening up for civil dialogue. You know, there are so many architecture competitions, you see something in the newspaper and they want you to vote for it. Well, maybe this could be used. You could put up a number of these stations around town and people could vote there. I should note that our interaction model on the binocular is based on not having any buttons or moving parts on the outside to keep complexity down. But you could have that in like a more controlled city environment. This is actually something we tried. It's a new skyscraper that's being built in Gothenburg, and you could actually visualize this. One of the people from the municipality came and saw this and was like, whoa, it's going to be that big. And it's other visualization. And my colleague Carolina, who's an industrial designer from Germany, who's an intern with us right now, she's working on this concept, designing the exterior both for the museum and also city planning. And I could talk a bit about later how we are thinking about adding heating elements, having this air pillar inside this binocular to create a good airflow and such for the smartphone hardware. But using weatherproof smartphones already makes this a much easier challenge to get hardware to survive outdoors. So many interesting opportunities with this kind of technology, and please email me or my colleague if you want to know more about this, and thank you for listening.